Welcome to Paripurna Academy. I am J. Tabital and today we are going to discuss on the topic of electromagnetic waves. So, these EM waves are created due to the oscillation or due to the vibration of the electric field as well as the magnetic field, and the wavelength and the frequency of this EM waves, that is the electromagnetic waves, will vary for a very long wavelength, likewise for extremely very short wavelength. And here we are going to discuss what is the source of the EM wave and what are the basic properties on this EM wave. Likewise, we are going to see the intensity of the EM waves, and finally we are going to see the electromagnetic spectrum, which was a very interesting topic, and finally we are going to do some problems based on these concepts. So, now let us move on to the presentation. So, before that we are going to see what is displacement current. So, it is that current which comes into existence, which means in addition of the conduction current whenever the electric field, so and the electric flux will change with respect to time. So, during the existence of the current in the electric field, the electric flux will change with respect to time. So, this is equal to epsilon naught times, that is the rate of change of the electric flux through a given surface. So, we can write it in the formula as ID is equal to epsilon naught into d phi E divided by dt, which is nothing but epsilon naught A into dE by dt. So, here comes the modified Ampere circuital law. So, in lower classes we will study the Ampere circuital law. Here we are going to see the modified Ampere circuital law. So, it states that the line integral of the magnetic field B over a closed path, which is equal to mu naught times the sum of the conduction current IC and the displacement current ID threading the closed path. So, this is the modified Ampere circuital law. So, that can be represented as integral of B vector into dl vector, which is equal to mu naught. So, the statement what we have learned here is in the form of a formula there. So, integral of the line integral of the magnetic field B over a closed path, that is why we are using that symbol for the closed path integral, and the sum of the conduction current IC and displacement current ID. So, you can see mu naught into IC plus ID. So, mu naught into IC plus the value of ID is epsilon naught d phi E by dt. So, the sum of the conduction and the displacement currents has an important property of continuity. So, these two currents have the property of continuity, that is the sum remains constant along any closed path. So, here comes the electromagnetic wave. This is the main topic of today's session. So, an electromagnetic wave is a wave which is radiated by an accelerated charge, that is the oscillating charge. So, we can say the charge which is moving. So, accelerated charge and which it will propagate through a space as coupled electric and magnetic fields, oscillating perpendicular to each other and to the direction of propagation of the waves. This is nothing but the electromagnetic waves that you can observe it from the image. So, where is the wavelength and the propagation of the waves, how it is propagating. So, that you can observe it from the image as well as for the electric field and the magnetic field. Now, we are going to see what is the source of an electromagnetic wave. So, an accelerating charge which produces this electromagnetic waves. So, we have seen before that. So, an electric charge which is oscillating harmonically with the frequency nu will generate this electromagnetic waves with the same frequency nu. So, an electric dipole is a basic source of this electromagnetic waves. So, the basic source is electric dipole. So that you can observe it from the image, the electric dipole. Likewise, an LC circuit containing the inductance L and the capacitance C, that's why it is called as LC circuit, which produces the electromagnetic waves of frequency. So this is also a source of electromagnetic waves. So nu equal to 1 divided by 2 pi root of the inductance and the capacitance, that is LC. So that the LC circuit, how it works, you can observe it from the image. Next we are going to see some basic properties of the electromagnetic waves. The first property is the electromagnetic waves, that is EM waves, are produced by accelerated charges and do not require any medium for their propagation. So these electromagnetic waves do not require any medium to travel. So it will propagate in a vacuum. So it does not need any medium to travel. Next property is the oscillations of vector E and B, it is the electric field and the magnetic fields, are perpendicular to each other as well as to the direction of propagation of the wave. So the electromagnetic waves are transverse in nature. So due to the oscillation of magnetic field and the electric field, which is perpendicular to each other, due to the direction of the propagation of the waves will be transverse in nature. The third property is the oscillations of electric field and the magnetic field are in the same phase, and all electromagnetic waves travel in the free space with the same speed, that is c, given by. So as we have seen before, the electromagnetic waves need not have any medium to propagate. So it will travel in the free space with the same speed c, that is given by c is equal to 1 by root of mu naught into epsilon naught, which is equal to 3 into 10 power 8 meter per second, that is the speed of the light. Next, a material medium of the refractive index n, then the speed of the electromagnetic wave is given by nu equal to 1 by root of mu epsilon, that is c divided by root of mu or epsilon r, which is nothing but c by n, that is the refractive index of a material. Next property is the ratio of the amplitudes of electric and the magnetic field. So the ratio of the amplitudes of the electric and magnetic field, that is E naught by B naught, is equal to C. So we know the value of C, which is 1 by root of mu naught into epsilon naught. The another property is the electromagnetic waves carry energy as they travel through space, and this energy is shared equally by the electric and the magnetic fields. Therefore, the average energy of the electromagnetic wave is U equal to UE plus UB, that is the energy of the electric field and the energy of the magnetic field. So half into epsilon naught E naught square plus B naught square by mu. So this is the average energy of the EM wave.